Hi, Sal.
Hi.
It's been a while.
It's been a while.
It's very interesting because we used to work together at Borealis.
That's
It's
right.
such a really research-heavy startup trying to productionize cutting-edge machine learning algorithms. So I wonder, how was your transition from such a focused research-heavy startup to a big financial company like RBC? And what are the challenges or differences that you're realizing every day?
Yeah, I think that's a really good question. I would say that AI product management is on a scale, so you have different product managers catering for different things within AI as well. So at Borealis AI, I would really consider myself as an infrastructure AI PM, and that really involved how do you actually go down in the technical details of how do you train large models, how do you do distributed training. It was very technical from that perspective. I was working on a use case. We were using high frequency trading. We were using deep learning and reinforcement learning to do high frequency trading. And that problem itself was not a consumer facing problem. It was on a trading desk. And the outcome was very simple. Either you made money or you did not make money. But the real complexity was in the technical details of how do you actually do inference, what are the latency requirements. So it was very research heavy, and the outcomes were very simple. Either you made money or you did not make money. So from a technical perspective, it was super challenging because you couldn't use any off-the-shelf TensorFlow, PyTorch models. You had to have your own infrastructure. So it was a lot about building that from ground up. In my current role at RBC, it's a very large enterprise, like you said. And so it's more around how do you prioritize AI features. And we are not building very complex models. We are really working on recommendations and ranking problems. But how do you tie that back to how much money is the bank making at the end of the day by doing better ranking or better recommendations? And that could be a very hard problem to solve because to connect like ML metrics to outcomes, business outcomes is very, very hard to do sometimes. And so I spend most of my time thinking about, hey, if I'm going to improve ranking in a particular feature, how does that actually add up? And is it a good enough feature for me to actually prioritize in the first place? So I think those are the key differences. I really like being on the consumer side, which I am right now. I get to think a lot about strategy from that perspective as well. But yeah, those are, I think, the differences between like being in a very technical role of AI and not being in a technical role, but they're still thinking about AI as a business strategy from that perspective. So, Mercer, you have moved to Microsoft, which is a big tech company. How do you see the difference between when you were working at Borealis and really looking at research versus now you're working as a part of a product team?
Yeah, so my opinion, the challenges I had at Borealis as a research company was that they're trying to innovate and introduce, I guess, new products for the bank. So you have to kind of find that opportunity. You have to prove that to the stakeholders. You have to build the infrastructure. So it's all up from the ground. And it's challenging in that sense that you're really starting from absolute zero in a lot of cases. You have to be ready to fail a lot and move fast. Microsoft is an established company with a lot of established products. So it's not like you have to find some sort of a use case or a machine learning algorithm and then look for a use case, look for something to solve. It's usually we have like a, very promising product. We know the challenges. We even know what kind of research can solve it. And it's about just moving fast and keeping up with the research and understanding the impact on user. So that aspect, that gathering feedback from the user would be very, very important. Whereas, kind of improving on the current features is very important by switching to better models and just being so agile and very fast. It's a big corporation, right? Yeah. So you have to work with a lot of different teams, and you have to make sure that you innovate as well as maintain. So these are kind of the additional, things that come into place comparing to Borealis. I think, it's a lot of, both have challenges, but different sort of challenges, yeah.
Yeah, so you touch upon a really good point over here about the difference between AI as a product and AI as a feature. Would you like to explain a bit more on that?
Yeah. So I believe AI as a product means that it has matured a lot, right? So it's basically we are building a product based on a machine learning algorithm. Like for example, the algorithmic trading platform you mentioned. That to me is AI as product.
Correct, yeah.
But let's say you have Teams, Microsoft Teams as an example. It's a product, it's a technology product, but it hasn't been AI based right off the bat. But it has a lot of different opportunities and features within it that can be improved using AI, that can be replaced by AI features. And eventually it could, evolve towards a more automated by AI product, but at the core of it is not an AI product, right? So, and I believe it's a really important evolution that we are going through in a lot of big tech companies, especially that to introduce, AI products, they need to start from introducing AI features, and then build up, as they are building the infrastructure, as they're building the confidence in other verticals of an org, as they learn how to maintain an AI feature or product, they can kind of evolve by shipping these features and then go towards a full-blown AI product.
Yeah, and I think I've seen a similar pattern as well. I've seen companies fail doing AI when they have a portfolio of AI where everything is a product. And so the entire experience depends upon AI working or not working. And that's a very, very risky route to go to, because at the start, AI is essentially very unpredictable. The outcomes could be very unpredictable. So if you are working on a product that is solely based on AI and you have never ever gone down that journey, you don't understand the issues that are going to come in, and a lot of projects fail because of that. As opposed to what Mercer is talking about, if you have a feature that is already working and you want to show small improvements using AI, that's a really good use case to start your journey. And over time, obviously, you learn through your mistakes and all, and you learn how to engage different researchers and engineers. There's so much learning as a part of the process. Going down the journey where you're starting as AI as a product would probably be the wrong start, especially for small organizations. Large organizations actually have a lot of money to throw around, so they can actually spend millions of dollars to get 1% accuracy on a particular algorithm, and they know they're going to get a lot of impact from that. But smaller companies who don't have a lot of resources, you want to be a part of features where a small improvement in accuracy results in a large impact. And being able to find that and communicate that to your stakeholders is the most important thing. You want to get confidence in your AI team, because AI projects can get shut down very quickly because they can be expensive. So you want to make sure that you have milestones and proof points where you can show progress along the journey as you're embarking on a bigger task. So that's one of the things that we found from our journey at Borealis as well. Mirza, how do you find interacting with engineers and researchers? Do you find it different from that perspective? What were some of your learnings from that, interacting with engineers and researchers?
I would say it's not that different. It's very, very similar. Maybe the main difference is that there are a lot of, as I said, because it's like a historically established company, established products, there's a lot of legacy knowledge that is there, so we have to make sure that we kind of ramp up to that, and engineers who have been around longer obviously have more information, have better knowledge of that system. And also, I think one of the other differences is that we also try to really work with the broader research community to further whatever area we're working in. So it's not just about improving our internal features and products. It's also we hold competitions in conferences worldwide and open source a lot of our data, and kind of invites researchers around the world to contribute and to learn from each other. And a lot of the times, they learn from us, they build up on our models, we build up on their models, and we use that and kind of give back to the research community and learn from them as well. And I think that's a great opportunity, and that has helped us improve on our models a lot. So that's one of the main, I guess, differences that I have felt between two companies.
Yeah, no, you're absolutely right. I think I see the same things as well. As managing engineering and managing research has a lot of overlap. And obviously, like with machine learning algorithms, it's more probabilistic, so you have to do a lot of like risk management on top of what you have been doing with engineering. But I find that there have been a lot of overlap, so that's absolutely right.
Yeah, so you mentioned risk management. So, or I guess one part of risk that I've been facing a lot, I can split it into two things. One is the stakeholder management and making sure you have their support and you're meeting their needs and you're, kind of having their confidence over time. And then the other part is having user confidence and positive user feedback and making sure what you're releasing is not actually making it harder for users to work, right? So how do you, at your current role, manage these two aspects? How do you get stakeholder, feedback? How do you get user feedback? And how do you combine them both to understand how to move forward?
Right. So I think I think you bring up a really good point. I think from a business perspective, I think we need to know about what our stakeholders actually care about. So most of them care about revenue, for instance. In certain cases, they care about, so revenue is a very lagging indicator, obviously. So we try to focus more towards engagement, retention. So usually our stakeholders are more concerned about, are your engagement numbers going up as a result of this ranking algorithm? Do you see more retention on your platform? Are people coming onto your platform again and again? Is the frequency of interaction increasing with the platform? So they care about more from those business metrics, as opposed to clients, they care about user experience. Mm-hmm. So sometimes those two things don't get along very well, and sometimes you have to sacrifice one for the other. But I think in terms of like machine learning from that perspective, I think from a client perspective, I think we have to make sure that there are so many things that can go wrong in a machine learning algorithm. The data could be, the data source could be bad, and it garbage in, garbage out. And so you have to make sure that if an algo fails for a particular reason, does it give a bad customer experience? A very good example could be, hey, you ask Alexa a question, instead of giving you a wrong answer, not giving you an answer is a better experience. So I think all of those experiences play a very important role, because machine learning algorithms fail in funny situations. And you should know all the edge cases, and the testing has to be very thorough, and you should have failovers and experiences around how to use the product in case if the product fails or gives a wrong prediction. So I think those are some of the things that we think about. Now, there are a lot of technical details around data drift and how do you capture that and all of those things which come as a result of that. We probably won't go into the details of that. But I think those are the important things that we go on a day-to-day basis at my place, yeah.
Yeah, there's certainly an element of surprise in machine learning products that is not in other tech products.
Yeah.
Sometimes, lose sight of really important things that you didn't even think of. And after production, you just realize, wow, I didn't even think of that. I didn't even go out there to collect that data.
That's right. And I think explainability becomes a really important aspect of it as well, especially when you're building trading applications, and trading applications such as it's a customer-facing trading applications. They want to know why the algorithm is making certain trading decisions. And explainability becomes a big use case. And especially if it's like very complex models like deep learning and reinforcement learning, they are extremely unexplainable. And so there's a lot of research that needs to be done in that space just to make them more explainable. Mm-hmm. And so there's always a careful balance between, hey, should we use a more explainable model, like a tree-based model over a deep learning model? But the deep learning model is more accurate as opposed to a tree-based model. So it lies on a spectrum, and you'd really have to figure out through a lot of user research and speaking to clients what they actually prefer. And so there's a lot of traditional product management that is involved as part of the AI product management. AI product management, I would say, is just 10% of the entire product management. So if you are really well versed with like product management principles, I would say if you are a consumer facing, not on the infrastructure side, you need to be very technical. But if you are a consumer facing AI product management, I think that is something that can be picked up really fast. But Mirza, your journey, you started off as a data scientist, and then you made your way into product management. So how was that?
Yeah, to me, it felt like a very natural transition, because first years of me working as a data scientist, I faced a lot of scenarios that I had to work on a product end to end, basically, and so being more than a data scientist, being involved in all aspects, and having that data science, machine learning, coding knowledge, going into product management gave me a lot of, I guess, valuable insights that I still use daily. Understanding the complexity of building certain models, understanding the requirements, knowing the blind spots, understanding the challenges that engineers may face when they get slow, how to unblock them faster. And understanding the importance of data collection and the challenges. I would say one of the things that is very, very important and very hard, even for Microsoft, which is a big corporation, with a lot of budget, is data collection and collecting good data fast enough, QAing that, making sure, we take into account bias, we take into account covering all the millions of scenarios that can happen in the real world. So I guess being a data scientist, that helps, right? That helps to look for the most important aspects and putting together really a spec for data collection, which is, I think, a new thing. We usually put specs for building a product together, we document that, but now data collection is so complex and so detailed that you need to really document it and make sure you're covering all aspects.
Awesome. Should we open it up to questions?
Yeah, sure. Mm-hmm. So much you can do with a rule-based system, right? Both in terms of accuracy and maintenance. So after some point, a rule-based system becomes too expensive to maintain and too error-prone to cover all the cases or the important cases to keep up with the real world, right? So I think you have to be aware of the cost that system has and kind of decide if it's worth it to switch that cost, right? So the expense, the cost that you're spending on maintaining a rule-based legacy system, adding if-else statements over time. At the same time, you may be able to build a model that covers a lot of that and would reduce cost and efficiency, and also maybe risk analysis to see what are the negative impacts of that legacy system, what areas it is missing or it's damaging or it's not covering, and then building justifications for replacing those with a more automated, smarter approach. I don't know, Salif.
Yeah, no, I think you covered everything. I think scalability is another important element of it. If you have user base which does not have overlapping characteristics, let's say you have millions of users and out of those, like 10,000 of those users are completely different from each other, where if an else system cannot capture all of those things, that's probably the time where you want to move to a more machine learning model where you learn from how they interact with your system as opposed to you explicitly telling them how to interact with your system. So I think those are the important characteristics when the user base is very large and there is no overlapping characteristics within the user base. If all the user base is doctors, for instance, and they're very similar in their nature, you probably do it within if-else assessment, but now you have nurses on the platform as well, and you have all different kind of user base. Learning from their data and how they interact with it is probably is one of the heuristics you can use to switch from an if-else to a machine learning based model. All right. Awesome. Thank you very much. Yeah, it was great having you guys here.
Yeah.
Thank you.
Thanks, everyone.